It's Don here from the board. Thanks for coming along and checking out this video. So you would have already seen in a previous video that I did an unboxing and had a quick look at the mini pottery wheel, a little 5-volt USB pottery wheel. So in this video, I'm going to have my first crack at actually trying to make something with it. It was something that I'd sort of been playing around with as an idea and concept because, as I said in the previous video, there are potentially little things that you can do like, part trays, screw trays and things like that. But what I'm going to try and put together today, whether it's successful or not, is I'm going to see if I can make a cylinder that might end up being a rotary encoder knob. So let's flip down onto the desktop and have a look at what I've got set up right now. So what you see here is I've just got a cardboard cereal box screen that I've sort of taped down to the desk. That's going to give a bit of protection and shelter to the rest of my desk and my monitor that you can sort of see just right here. What I've got is obviously there's the rotary encoder knob that I'm going to be modeling against, and there's the actual little USB mini pottery wheel. I've got a little container here for some water and a bit of chucks because I don't have a sponge, and I've just put a rubber band around that so it acts kind of like a sponge. I have a variety of silicon tipped tools that I got ages ago for working with polymer clay for the purposes of doing artisans, as well as some other rounded tools there, a bit of a blunt dissecting scalpel that I've used previously for my artisan works, a blunt probe. I've got a clear flat acrylic plate. Now you can buy these from craft stores because typically these are used for the press cutters. Like they have templates that you can put paper and craft and things like that, and it goes through and it pushes the actual cutter through the material. So these are just straight up a couple of mil. I think this is 3 mil or something like that acrylic. And here is some clay. Now this video is not sponsored at all by Argillo, but it took me ages to find an actual small volume clay that I could purchase, which was not polymer clay, because you can't fire polymer clay in a conventional kiln or in a pit fire because it's not clay. Even air dry clay doesn't work that way. So it took me a while to find a small volume that wasn't 5, 10, 15 kilos. And this Argillo stuff comes in a 1.5 kilos. So you can see, it's quite a small package, as it says, for educational use, but it's a 100% natural pottery clay. You can fire this stuff apparently at 970 degrees to 1050 degrees Celsius to a bisque fire. And coming up after this, if I'm successful in actually making something, I'm going to have a crack at actually firing this at home using my barbecue and charcoal. But that's, the next step really after this. So I bought a small volume to play with because obviously if I'm doing miniature things, I don't need 5 kilos of the stuff. And it's a lot easier to manage and handle. And I've purchased a little Tupperware type container. Not that it's Tupperware, it's just a plastic container that I can keep it airtight in so it doesn't fully dry out. And then, so we will have a crack at making that. So I'm going to be aiming for something that's around 20 millimeters to 25 millimeters in diameter. I'm looking about 20 to 25 in height. And I need to make an internal bore roughly 5 to 6 millimeters wide. Now I know that clay will shrink when it dries, and I know that clay will also shrink when fired. So when it dries, I can increase the size by using files and scrapers to remove excess material, but when it fires, it's going to be set. So we'll see how that goes, but obviously as experimentation is, you won't know what the shrink percentage is like until you actually make it, until you actually go through that process. So we'll see how it goes. So that's what I just wanted to show with the setup. And I'll go and do a time-lapse thing as per usual, because I'm sure there'll be interruptions. I need to put on dinner later on. I don't know how long this is going to take. I don't know how messy it's going to get. So we'll see what we end up with. And obviously we'll come back after the time lapse and hopefully this won't be a complete disaster, and talk about what that experience was like and uh, where I got to. I really don't know what I'm going to be expecting here. So we'll see you shortly on the other side. Okay, so hopefully what you would have seen is the time lapse of that process. That was about half an hour or so of work, and I do want to call it work because it was work. And this is the end result. So I have a, I don't really want to turn it sideways too much because it's probably just going to fall off. But there it is. I have almost a cylinder. It's a little bit fatter in some areas than others. And you'll see that I've managed to sort of core out on top of it and kind of smooth it. Now, some observations for this wheel is that it's extremely underpowered. Now that's not really surprising because it's only a 5-volt device. I did find that I had to run this at about 75 to 80% of its maximum speed to really be able to do anything at all with the clay. And even running at that maximum speed, I had to be very delicate, I had to be very gentle with it, because obviously applying too much pressure and too much resistance to the spinning of this motor stopped it. It just doesn't have enough torque to go with it. Now, I don't know what this motor's maximum voltage is, but it is running off 5 volts. And the reason why I know that is because I opened it up earlier to doing this today, and I plugged it into the USB. I did run it all the way up to maximum speed, and I tested it with my multimeter, and it was pulling 4.9 volts. It does have a circuit board in it that is hooked up to the dial as a voltage divider, which just goes out straight to the motor with a plus and minus. Now, if I know what the rating is of that motor, I could potentially rejig it to an external power supply that's not USB and drive it to 9 volt, 12 volts, 24 volts if the motor can take it. That won't necessarily give it more torque, it'll just give it more speed. But with more speed, it will probably be, I don't know, maybe easier to work with. I'm not 100% sure. Now, I'm very glad that I set up this screen because you'll see there is a ring arc of splatter around here, and it was going up my arms. There's some on my pants. There's some spots on my shirts. There's probably some random spots, very fine aspirated drops that have gone out somewhere else as well. But I did try to catch most of it with my hand, as you would have seen closed in here. Observationally, this Argillo CO2 stuff is actually really easy to work with. It's quite soft, and wetting it's holding its properties quite well. I obviously put too much to start with because I really didn't know what it was going to be like, and I pulled about double what I really needed to start with. And using the tools, I didn't realize this first conical one is actually, it's got a curvature in it, and I didn't realize that, and that's why it was really throwing me off on what it was doing until I realized it had that curve, and then I just went to the straight up flat chisel tip that I was using later on to help get the sides. But working with the chucks, or if you had a sponge, definitely gave me the best results. You know, it's a little bit uneven on the sides here, but when this fully dries, you can work with it. And my intent here is not to put it back on this, but I'm going to try and mount it on my mini lathe and use that to smooth and sand and turn down the sides to a bit more of an even diameter. Now the inside, so I was measuring with this, and now it's all a bit clay and a bit dusty. is 6 mil across the post. It's 6 mils across the post here, and I've got greater than 6 mil. The reason for that is I know there's going to be shrinkage. I just don't know how much there's going to be shrinkage. And secondly, clay is not plastic. It's not flexible when it's fired, which means if it's the perfect size and you force it down, it's going to crack. So you're still going to need some kind of in-between medium, which whether it's, plastic wrap, whether it's just a bit of wax or just paper wrapped around it, you're going to have to shim the encoder against that knob. Or if you get one of those plastic inserts, and you can put the insert around this or this and then push them together. So having it slightly larger is not an issue. The depth is really hard to measure right now because it's so wet. I don't want to try and get it perfect. And once it dries out a bit and it's a bit firmer, before firing, once again, potentially on the lathe, I could go in there and cut out a bit more material to get the depth that I want so it'll sit down far enough on the encoder. So as far as it goes, I'm actually really happy with how far I've got with it and what my end result is. Look, it's amateur. I know it's not perfect. It's never going to be for somebody who's literally played with clay for the first time since high school, which was a really long time ago. My daughter's played with clay, not that long ago compared to me when she's done it at daycare. Other things that I want to make observational in regards to this unit that is, I suppose, a quality of life thing. This knob is too small and too hard to turn when your fingers are wet. It really needs to be replaced with something like a wing nut that has bigger grip on it so it's easy to manipulate, because right now with the tiny little bumps on it, it's really hard to turn. So I might end up modifying that, gluing it, taping it, bulking it up so it's just big. Of course, if this works, I can make another one, and then if I fire that and that works, I can shove it onto there, and I end up with a big ceramic dial that will be the speed control on this unit as well. So that's it for this particular part. I'm going to let this dry. It's probably going to take a number of days before this dries. Then I'll try and whack it onto the mini lathe. We'll see if we can do a video on that. And then we'll have to tackle the big if I can fire that on my barbecue using charcoal and a hairdryer to get the charcoal temperatures up. What was that? Red barbecue? Yeah, our red barbecue. Our red barbecue out the back. Alright, well, that's it for this video. Thank you very much for checking out this video. If you like this kind of stuff, if you think, what I do is entertaining, different, a bit wacky, not even got there yet, Missy. They can't even see you. I've got a chip. I've got a little bit of a munchkin down here who wants to get involved. So, yeah, if you like this kind of stuff, please hit that like button. Hit that bell notification so you get notified when the next videos come out. And of course, subscribe so you'll be able to see all of the latest, greatest, wackiest, craziest mechanical keyboard kind of related stuff that we do here. So just finding my mouse so I can stop the recording. You need to be louder than that so they can hear you. So wait until it's the right time. Yeah? Alright. So, as usual, until next time.
Happy clacking.
Louder.
Happy clacking.
Happy clacking.